So I was giving you a formula on how to predict the number of electrons in a shell. Now, just to remind you, we said that a nucleus will have protons and neutrons, and surrounding it is going to be the energy shell. This is the structure of an atom. It's spherical. So if this is energy shell 1, this 2, and then probably you have 3, 4, depending on the size of the atom, then those will be shells, okay, counting from the one closest to the nucleus. Okay, so you can predict the number of electrons in this shell using this formula. The formula is 2n squared. Okay, formula is 2n squared, where n equals to shell number. So if you're in shell number 1, n equals to 1. So how many electrons in shell 1? Should be 2n squared, shell 1 squared. So obviously that's 2, and that's what you see over there. So number of electrons in shell 2, n equals to 2, that's shell 2. So it's 2 times 4, obviously the number is 8. Number of electrons in shell 3 is 2 times 3 squared, which is 2 times 9, gives you 18. So let's say we had shell 4. Number of electrons in shell 4, okay, so shell 4, number of electrons in shell 4 will be 2, 4 squared, which is 2 times 16 is 32. So it should have been 32. Let's say you had shell 5, okay, the number of electrons will be 2n squared, which is 2, 5 squared, which is what? 2 times 25, which is 50 electrons in the fifth shell. Let's say you had shell 6. Formula is 2n squared for number of electrons, so 2, 6 squared, which is 2 times 36, which will be 72, and so on and so forth. So that clears that part that I wanted to iron out. So let's do an example on electronic configuration of, for example, neon. Neon is in main group 8. Remember how I said you count main groups like this? Okay, so that's not an 8. Let me erase this. So that's supposed to be main group 2. Ignore the transition metal elements. This will be main group 3, 4, 5, 6, 7, 8. That are those numbers also represents number of valence electrons. So neon is in main group 8. Okay. What is the electronic configuration of neon? Okay. So we need a pen. So it happens that neon has atomic number of 10. Okay. So if neon has atomic number of 10, we'll first of all go through 1s. Remember, s orbital will always take a maximum of 2 electrons. Okay, p will take 6 electrons. 6 electrons. S will take 2 electrons. D orbital will take 10 electrons, and then F will take 14 electrons. So you will go 1s2. So this is done, and then go back to your tail. 2s2 in the pyramid, and then go back to the tail, you get 2p. P takes a maximum of 6. If you count 2 plus 2 plus 2, this gives you 10. So this is the electronic configuration of neon. Let me take magnesium. Oh, and if you want to determine the valence electrons, the most outermost shell would be a 2, which means you have a nucleus and 2 circles. So this will be a 2. And in the outermost electrons, you have 8 electrons. Those are 8 valent electrons. Okay. All right. So that's why neon is in group 8. It has 8 valent electrons. So let's do another example. Let's say we are looking at aluminum. So electronic configuration of aluminum, atomic number of aluminum is 13. How do I know that? Atomic number is usually the smaller number in the box in the periodic table. So again, we're gonna cross 1s. S carries a maximum of 2. Then we cross 2s. S carries a maximum of 2. We are not yet covered the 13, so we keep going. Next, we cross 2p. P carries a maximum of 6. We are at 10. We have 3 more, so we have to go to 3s. S carries a maximum of 2. We have 1 more, so we have to go to 3p. Okay, so that accounts for 13 electrons. So in terms of valence electrons, the outermost electrons, since we went to the third shell, so the valence electrons will be 2 plus 1, which is 3 valent electrons. Yeah, so you have 3 electrons, so 3 valence electrons, and in your periodic table, aluminum is in the third main group. So that's how you get valences. So you see you have 3 valence electrons there, and then we did neon. Neon has 8 valent electrons. So that's how you do it, especially for elements in groups other than the transition metal elements. Okay. All right.